Okay, back. Okay, so again, yeah, this bolt upgraded. Everything's perfect. Everything's great. It moves everything fine. One other thing I was noticing with one of these motors, the actually, yeah, the one of these stepper motors was actually when it was bolted to the frame, it actually had crushed one of the PWM wires and may or may not have been grounding out to the motor itself. But anyway, I noticed that and corrected it. I got some images and some photos of that I took when I found out. Um, okay. Again, the cooling fans. You can see there's one back there as well. Cooling fan on the stepper motors there. Um, okay, now to get into the guts. So I'm going to actually turn it off so that we can maybe. No, I'll do this. Hold up. Second. Kill it here. Don't. No. Nobody falls. Nobody falls. Okay. Sorry. All right. Now, here's what's been added to the bottom of the unit. All right. So, I gotta get that out of the way there. Again, these are the clips for the Alta controller up front. There's a 4 gig card out there if you need to actually move something. I don't know why you would now, but it's out there. This upgraded panel, again from another bot. I printed that and added some 50 mil. I think they're 50 mil fans, and shrouded properly to cool the stepper drivers. That's been printed as well and added to facilitate it. These feet have been added. Everything is attached here with double-sided, either double-sided tape or Velcro. There's Velcro straps that literally hold all this into place. So, a couple things you notice down here. Off of the 24 volt that's coming in, it comes down to this small proto board that I've added here. And what this is a 1 amp switching 5 volt 1 amp switching regulator, high efficiency, to provide 5 volt for this Raspberry Pi. There's a large input cap, just because sometimes if USB devices on a Raspberry Pi are removed or inserted, or actually when they're inserted, there's a large current flow. There's a large current sink to some USB devices, and sometimes it'll actually cause enough of a dip on the 5 volt rail to disrupt the operation of the Pi, and it'll actually reboot. So if anybody is plugging in switching USB gear on a Pi and it reboots, that's why. So a hefty input cap, because this lead is actually bypassing the built-in thermal fuse and going straight to the 5 volt test points on this our Pi. It's dedicated to this printer now. It has a small wireless adapter right there off the front, as well as where the camera feeds into. It's a 32 gig SD card running off the back of it there, and again this powers up whenever the printer is powered up, and communication wise it comes out and just simply loops back in and stands up a web server and runs Octoprint, which is just indispensable now that I know about it. This is the lead for the heated bed, and this is the lead for the PWM for heater 2, or for maybe heater 3. Yeah, for heater 3 for the heated bed. Waiting on a solid state ceramic relay, a 32 amp solid state relay to control the heating element for the bed. But then once that's there, the heated bed will be hooked up. This regulator right here actually provides, I think, close to 3.7 volt for all of the cooling fans for the steppers. They were quite loud at the full 12 volt. So I actually put in one of these adjustable switching rate. That pot right there can change them. And what I did was I dialed the voltage down in parallel across all the fans until they almost nearly stopped and ran very, very quiet, because they don't actually need to provide very much cooling at all to be effective. They don't need to move an awful lot of air. So that's pretty much everything on the bottom of the board. Again, as soon as the unit is switched on and powered up, 5 volts to the Pi, and I think roughly 3.7 to the stepper cooler motors there, cooler fans. This one doesn't move very often at all, so no cooling on it. Okay, let's flip this back up, and maybe I'll go over and see if I missed anything. Okay, again, this is not in use yet, but it's still hooked up. I'll put a glass platform up here. I'll come to within a couple mils of the screws on each side to get a good glass platform up there. Underneath that tape is actually Kapton tape. Got a whole bunch of Kapton tape for the heated bed. And that just sits right in there. I don't think there's anything else really. That's pretty much it. Printing out some parametric chain links for that cable. Come on. And then Octoprint. Right? So even on a first gen Raspberry Pi, very, very, very neat. Right. Right. You upload your G code, load it, hit print. Right. You can monitor temperature. I had to redo the PID timing for 24 volt because the heater element is now running at 24 volt. But once it was tuned, it works very well, and the extra oomph of that 24 volt DC supply is significant. It comes up to temperature really well, really quick, and is much, much more stable than it was on your 19 volt adapter. The original 19 volt adapter showed there was an awful lot of noise. I'm not sure if you ever would have noticed it, but the temperatures would bounce around a lot. Anyway, that's been pretty much solved there now. Okay, I think this is enough for now.